Okay, so this is the optional video, how to do half reactions, how to do balancing redox without half reactions. It's kind of a shortcut. You cannot do this if they ask you to do half reactions. You can only do this if they're just asking you to give them a balanced net ionic equation. If they say by half reaction, you have to do it the way that we already learned it. But what we're going to do right now is the shortcuts. This is really easy to use on multiple choice. Basically, it's the same idea, but rather than rewriting everything over and over and over again, you're going to kind of use a bracket and multiply the coefficients as they are, and then everything else kind of works the same, except you don't cut it in half. So I'm just going to kind of show you how this works. The first thing that I need to do is figure out the oxidation number of everything in my equation so I know what's changing. So I can look at this and see that probably the oxygen won't be changing, but the iron and the carbon, let's see what we've got. So in the first on the left, the iron is actually 3 plus, or plus 3 for an oxidation number, and on the right it's 0 because it's an element. On the left, the carbon is going to be plus 2 because it's with oxygen, which is minus 2. And on the right, it's going to be plus 4 because it's with 2 oxygen. So that's the first step. Then I'm going to come in and I'm going to balance anything other than oxygen and hydrogen. So I can see that I have 2 iron on the left. I need to put a 2 in front of the iron on the right. But my carbon is the same on both sides. Now I'm going to connect my products and my reactants with brackets. So I'm going to connect a bracket for the 3 plus to 0, which will be the reduction half. And I'm going to connect a bracket from the 2 plus to 4 plus for the carbon, which will be the oxidation half. You have to have one of each, so it's really helpful to always stop and check that you have that before you keep going. I'm going to write the number of electrons that were transferred. So I'm going to start with the carbon. It's easier. From 2 plus to 4 plus, that's a difference of 2 electrons. I'm going to write that on the bracket. The iron is from 3 plus to 0, but there are 2 iron doing that. So 3 plus to 0 is 3 times 2 is 6 electrons, and I'm going to write that on the bracket. I need to come back in and multiply the number of electrons in each to match. So I don't need to multiply the 6, but I need to multiply the 3. And I'm going to take that 3 and put it in front of the carbon dioxide and in front of the carbon monoxide. Let's just say that I needed to multiply the iron. I would have to multiply whatever my multiplier is by that coefficient of 2. So technically this is times 1, which means I'm putting a coefficient of 1 in front of that, and I'm putting a coefficient of 1 times 2, or 2, in front of the iron on the right. So I don't usually write that out if it's just times 1. All right, now that I've done that, I'm going to come back in and balance the oxygen first and then the hydrogen. So I have to count really carefully. I see on the left that I have 3 and 3 more is 6 oxygen on the left, and on the right I have 3 times 2 is 6 oxygen, which means that I don't need to add water, which means that I don't need to add hydrogen ions. And yet if I had done this by half reaction, I would have had to make them both acidic, and I would have had to then cancel out all those hydrogens and waters, and it would have been a big mess. But right now, I think I'm finished. So I'm going to check substance and charge. I have 2 iron and 2 iron. I have 3 and 3 is 6 and 6 oxygen. I have 3 carbon and 3 carbon. The total charge on the left is neutral because those are both compounds. The total charge on the right is neutral because those are both compounds. I'm done, and my final equation looks like this. Okay, I'm going to do one more, and we'll do this in an acid because this time we will need to do that. So let's see what's happening. I have copper with an oxidation number of 0 going to 2 plus. I have nitrogen in nitrate as plus 5, and I have nitrogen in nitrogen dioxide as plus 2. So I have this, which is an oxidation half, and I have this, which is a reduction half. So that's good. Okay, I'm going to balance the copper or the nitrogen, but they're already balanced, so I don't need to do that. I'm going to decide how many electrons transfer. So from 0 to 2 plus is 2 electrons for the copper, and from 5 to 2 is 3 electrons for the nitrogen. I'm going to come back in and I'm going to multiply the 3 times 2 and the 2 times 3. And I'm going to make those coefficients on what they're attached to. So it will be 3 NOs and 3 NO31 minuses. Sorry, I just did that wrong. It will be 2, the 2 goes on the NOs, and the 2 goes on the NO3 minuses, and the 3 goes on the 2 coppers. Now when I check it, I see that I have 6 oxygen on the left and only 2 oxygen on the right. So I'm going to have to come back in and add 4 water to take care of the oxygen. Now that means I added 8 hydrogen, so I'm going to add H pluses, 8 of them, to take care of the hydrogen. And I think I'm done. So I'm going to check the substance and charge and see what I've got. So now I have all my substances are good. On the left-hand side, I have 2 nitrates, that's -2. And I have 8 positives, that's +8. So that's a total of +6. And on the right, my nitrogen monoxide is neutral, but my copper gives me a total of +6. So I'm done. I'm going to rewrite this because it's kind of a mess. But I got 3Cu plus 2 NO31 minus yields 3Cu2 plus and 2 NO. And you're really going to like this because, oh, sorry, I forgot my hydrogen and, let me start over. I forgot my waters, sorry. I have +8 hydrogen ions on the left, and then I have 3Cu2 plus and 2 NO and 4 water on the right. So I ran out of space there, sorry, but what I have is that as my equation. So you guys are going to really like this shortcut, but the problem is that if you are asked to do it by half reaction, you have to do it the other way. So you can try it this way if you want. If you don't want to and you want to do it the other way, you're always welcome to do them the other way, but kind of keep that in mind.